Good morning. Welcome and thank you for attending ACEEE's webinar on intelligent efficiency. My name is Maggie Molina. I'm a senior manager here at ACEEE, and I will be your moderator for this meeting. Immediately following today's webinar at 1:30 Eastern Time, ACEEE will release our new report on intelligent efficiency. But first, we wanted to take this time and hold a webinar to discuss the report with members of our community. Our goal today is to provide you all with an overview of a new concept and framework for intelligent efficiency, which is a systems-based or holistic approach to energy efficiency. We have several experts, both from ACEEE and from leading U.S. corporations, who will share specific examples of intelligent efficiency and explain how this resource can outstrip the impact of energy efficiency as it is understood today. Our speakers today are Neil Elliott, Associate Director for Research with ACEEE, Paul Hamilton, Vice President, Government Affairs with Schneider Electric, Clay Nessler, Vice President, Global Energy and Sustainability with Johnson Controls, Larry Plum, Executive Director for Emerging Issues and Technology Policy with Verizon, Arkady Gurney, Senior Director for Policy with OPower, and Stephen Harper, Global Director for the Environment with Intel Corporation. First, let me just provide a couple of notes on the technical side. Your phones will be muted for the entire session, so you'll be able to hear the speakers very clearly. This meeting will be about an hour in length, and our speakers will present for about 45 minutes. Following the presentations, there will be a short Q&A session when our experts will answer your questions live. To submit your questions online, just click the Q&A button on the top gray bar and type in your question. We'll try to address as many questions as possible. This meeting is being recorded, and we'll send you a link to replay the webinar and view the PowerPoint slides later this afternoon. If you do need any technical assistance on the call, please call 1-877-283-7062 for any technical help. Thanks again for joining us today. Now let's get started first with ACEEE's Research Director, Neil Elliott, who will provide an overview of ACEEE's new report on intelligent efficiency. Neil?
Thank you, Maggie, and thanks everybody for joining us this afternoon. I want to start by talking a little bit about where energy efficiency has gotten us in the past. If we go back over the last 35, 40 years, what we see is that energy efficiency, as we've known it, has been a major contributor towards meeting the energy needs of the United States. As we look forward, though, we need to perhaps broaden our horizons for what we think of as energy efficiency. Most of the big efficiency hits that have come from the work over the last 4 decades have really been focused on device efficiencies, whether we're talking about efficiencies of cars, light bulbs, appliances, or other pieces of equipment. And while there is a significant potential that remains for device efficiency, there is an even greater efficiency opportunity that exists for systems. Systems, however, are by nature complex, and as a result, what we need is a different approach if we were to go after the efficiency opportunities in systems. If we start to look at devices, devices are really parts of systems, and if we go in and we try to improve the efficiency of an individual device, we don't necessarily improve the efficiency of the overall system, and in some cases can actually increase energy use. As I said earlier, the low-hanging efficiency opportunities, we've really harvested a lot of those over the last 4 decades. And so as we look more at additional device-focused policies, we see them producing more and more modest returns, typically more in the 2 to 5% efficiency improvements. However, we have a lot of experience looking at really optimizing energy use in systems, and the opportunities there are far greater. This report took a look at just what we call information and communications enabled efficiency technologies, and we see those producing efficiency improvements in the 12 to 22% range. And we have some evidence from the field that when we begin to integrate these systems, we get network effects. We get improvements that are beyond just the individual system improvements, and so we could look at the sort of 12 to 22% as the bottom line. Now, what does this have to do with intelligence? Well, computer sensors, communication advances are really what are enabling us to improve those systems' efficiencies. So this represents the future of what we think will be energy efficiency going into the 21st century. And we've characterized this as intelligent efficiency. And what this is intelligent efficiency is a system-based, holistic approach to energy savings that is really enabled by information and communications technologies, as well, and this is important, the user's ability to access real-time information and make decisions. Intelligent efficiency differs from the device or component energy efficiency in that it is adaptive, it's anticipatory, and it's networked. So what we really see is an intelligence that is emerging that is realizing those system efficiency opportunities that exist out there. Now, when we started to work through this over the last 2.5 years, we began to try to develop a taxonomy of intelligent efficiency. And what we found were there really were 3 sort of key types of intelligent efficiency that are manifesting themselves. The first, and one which we think is going to be really important moving forward, is what we call people-centered efficiency. And this is the idea that the individual, the operator, the owner of a piece of equipment is in a position to make decisions about efficiency if they're given real-time information and the tools that are necessary to realize that. So we see this with things like home energy monitors, fuel economy displays. We also have what we call technology-centered efficiency. And this is really moving beyond what we have traditionally thought about in automation, really to looking at systems for buildings, manufacturing, transportation, power that are able to use sensors, controls, and software to optimize in a dynamic and anticipatory manner the efficiency of the system. The final kind of intelligent efficiency is what we call service-oriented efficiency. Also a term, another term that's used for this is the dematerialization. And this is the idea of using information communications technologies, whether this is broadband, computers, et cetera, and substituting those for more physical attributes. Today's webinar is a perfect example of this. We have over 1,200 people participating today, and they're doing it using the magic of the internet and communications technologies and not having to actually physically travel and join in a physical location. Realizing system efficiency is really an important issue, but when we talk about systems, I think there's a lot of confusion, and it's a complex construct. But what we're trying to do is meet the needs. And when we talk about systems, what we're actually looking at are a series of levels of efficiency or levels of systems that exist. And these move from a single process, such as heating or cooling a building, up to really integrating at a facility level, perhaps even moving into a community level where we're seeing an entire campus or even a downtown urban core become a key element, and then finally to an economy-wide where we're seeing communications and networking really transforming the future of energy use in the economy. So what are the policy opportunities? That's what ACEEE is known for. Well, first I think is just recognizing and building awareness of what is intelligent efficiency becomes an important opportunity. And the opportunities are for government and private sector to really lead by example. And we see some of the companies who will be speaking shortly will be talking about how the government and private sector are leading. It's going to be important to access up-to-date, reliable, and meaningful energy information, and that's going to be a challenge that is really going to be an open source challenge that we'll need to deal with. Certainly, a lot of people have concerns about this idea of the Internet and concerns about privacy, and so it'll be important to address those in a way that provides an open flow of information while addressing privacy concerns. Another important thing is really shifting the way we evaluate and the way we operate for many of the regulated utilities like electricity and gas, and moving really for more performance-based metrics, performance-based evaluation approaches, because intelligent efficiency is not device efficiency. Finally, supporting the infrastructure, expanded broadband, expanded data are all critical factors, as is the continued encouragement of innovation within the marketplace. The work that we've been doing over the last 2.5 years has been informed by an advisory group, and the firms that are referenced here represent some of the leading companies in areas such as communications, computer technology, engineering services, as well as electric utilities. And this group has, in itself, been a motivating factor in trying to define what is intelligent efficiency. Intelligent efficiency is complex, and it's very multidimensional, and maybe one of the best ways to understand it is through some examples. Intelligent efficiency is new, but it's been emerging over probably for the last decade, and it is now factoring critically into business strategies for many of the companies that are listed as well as others. So in a lot of ways, I think this is probably best understood by taking a look at some examples, and our next speakers will give you some examples of where we can go on this. Thank you very much for participating today, and I look forward to taking your questions shortly. Thank you.
Great. Thank you, Neil. Let's turn it over next to Paul Hamilton with Schneider Electric. And let me just ask, please, for all the speakers to please speak as loudly as possible. Thanks, Paul.
Thank you. Thanks, Neil. This is Paul Hamilton. Schneider Electric is a company engaged in energy management across all aspects of industry, buildings, infrastructure, and transportation. We're a global specialist in energy management, providing really an integrated approach designed for the capabilities of the current digital economy. Our approach has been one of evolving integrated architectures, in our case ecostructure, to address the complex opportunities afforded by the emergence of intelligent efficiency. For the purpose of this discussion, I'd like to address the role of intelligent efficiency in industry. Industrial productivity and efficiency have been evolving for some time, as Neil said, really based on the development of energy-efficient devices such as motors, automation such as motor drives, programmable logic controllers, PLCs, and SCADA systems, all integrated with manufacturing execution systems really designed to run operations. So what we see is that most of the industrial users have completed most of the basic energy efficiency upgrades, but also few have taken full advantage of intelligent efficiency. They've really not taken full advantage of all the tools they have to integrate everything and optimize the efficiency. The real opportunity for industry going forward is the use of the three efficiency categories mentioned before: people, technology, and service-centered categories. This can best be demonstrated by one of our offers for industrial users called Production Energy Management. In this application, we first provide energy action plans to upgrade or automate the systems to be very efficient in an industrial site. We then use metering and monitoring systems to collect real-time energy usage data along with the manufacturing execution system, which is really used to monitor the traditional KPIs within a plant system. The Production Energy Management System, or PEO, then uses analytics software to look at energy costs per unit right along with production conditions such as supply chain events, weather, utility cost, commodity cost. And using this PEO, we can really help identify reasons for anomalies or identify the anomalies in a facility, in addition to understanding how the energy is being managed at the site. This can be used to guide management, developing preventive plan to reduce or stop the occurrences. So really, this is a system that by integrating the technology-based energy efficiency tools, plus the data collection tools, plus the people-centered activity of analyzing this stuff, or software analytics and the people making decisions on it, we can really optimize energy use in a facility. So PEO provides the context for abnormal energy events that are critical to understanding energy use and really over or under performance in operations. We've used this system in a number of places to really get significant energy reductions. Primary applications have been mining and metals. It's really a great example of using all three categories of intelligent efficiency that were identified earlier. At Schneider Electric, we see intelligent efficiency as the convergence of energy infrastructure and data, and this is the next big opportunity in industrial energy efficiency.
Great. Thank you, Paul. Clearly, the industrial sector is ripe for intelligent efficiency opportunities. So next, let's go to Clay Nestler with Johnson Controls. Clay?
Hi, everyone. Thank you very much to the ACEEE for inviting me today. I'd like to talk about a very specific project, the Empire State Building retrofit. This is a project which started a number of years ago by a cross-functional expert team. It included ourselves, Jones Lang LaSalle, the Clinton Climate Initiative, and the Rocky Mountain Institute. What we did is we went through a very holistic process to identify opportunities to reduce the energy use in the Empire State Building. Tony Malkin, who's the owner of the Empire State Building, wanted to, one, prove the case for deep energy retrofits, and he wanted to not only prove that he could make significant reductions in an 80-year-old building, but that it was very cost-effective and provided a good business case. The secondary goal was to produce a replicable model which others could follow in retrofitting their buildings. Many people have heard about the Empire State Building retrofit. Some of the more interesting anecdotes are the remanufacturing of 6,514 windows, 75 a night on a factory hidden away on the 5th floor. What I'd like to do is emphasize some of the aspects of the retrofit which directly relate to intelligent efficiency. There were three areas of intelligent efficiency which have all been demonstrated through the Empire State Building project. One was focused on upgrading the analog controls that were part of the original building. Most buildings, particularly those 80 years old, had pneumatic or analog controls that provided the majority of the equipment control as well as the space controls. As part of this retrofit, they were all upgraded to modern digital controls, which provided greater efficiency for the equipment and obviously greater comfort for the occupants as well. One of the interesting aspects of the Empire State Building project, it is one of the largest wireless sensing installations in the world. You can imagine the challenges of running lots of conduit and wiring and communication signals to a lot of additional devices throughout the space. Wireless sensors using Zigbee communications that self-configure themselves and are very flexible were used to provide that additional information. One of the side benefits was we found the majority of tenants actually moving the thermostats over time, taking them away from a copier or a coffee maker where they're getting a false signal to areas which better represent the comfort in the zone. We're also very extroverted in the use of occupancy sensing, measuring occupancy in conference rooms, measuring occupancy to automatically switch off plug loads, as well as using carbon dioxide sensing in the conference rooms and other areas. The second area of intelligent efficiency is people-centered efficiency. For the Empire State Building project, we developed a very specific tenant energy management portal. This is a portal that all tenants within the building get, which shows them their energy use on a half-hour basis. What's interesting about this particular application is it not only tells them the energy they're using, but it normalizes it with respect to primary characteristics such as square feet, number of people occupied, hours of use, but it also allows them to compare their energy intensity with other tenants in the building. So let's say that you're an accounting firm on the 6th floor. You are able to not only compare your performance over time, you're able to compare your performance with others within the building and in fact opt into groups where you could compare with other accounting firms. You can imagine the challenges which are starting to occur as tenants try to see who can run their or operate within their facilities most efficiently. The third area is service-centered efficiency or service-oriented efficiency. One of the things we did with the Empire State Building, it is such a large and such a complex system, is that every piece of equipment, every system is continuously monitored outside the Empire State Building at a remote operations center. Sophisticated analytics, fault detection, and diagnostic algorithms are run on a continuous basis on the building to make sure that it's actually operating as intended. That's very important to be able to assure that the improvements we've made sustain and in fact improve over time. I think it's a great example of service-centered efficiency. We're rolling a lot less trucks. When a truck does roll to make a repair, it knows exactly what system has failed and what parts are needed to repair it. And I think it is a good example of the potential for this particular form of efficiency. Net-net, the Empire State Building will save 38% in its energy use and have a payback of 3 years. But what's very interesting is what this chart shows is that in that 38% reduction, 4 specific improvement measures, direct digital control, tenant daylighting and plugs controlled by occupancy, the tenant energy management system and demand controlled ventilation are all great examples of intelligent efficiency, and they sum up to over half of the savings. So 20% out of the 38% reduction are actually driven through intelligent efficiency. I think it's a great case study, and we just announced last week that after 1 year since the project was completed of the core building improvements, we actually exceeded the guaranteed performance levels by 5%. So everybody's very happy with this project, and I think intelligent efficiency has great potential impact in the future. Back to the organizers.
Great, thanks Clay. And let me just quickly mention that in the report that we're releasing this afternoon, there are case studies on both this example as well as the prior example in industrial smart manufacturing. So next, let's go to Larry Plum with Verizon. Larry?
Hi, thanks for inviting us and having this presentation and this report at ACEEE. Many folks may think of Verizon as a communications company, but also through the application of machine-to-machine communications and broadband infrastructure and so on, we are increasingly involved in modernizing the electric grid and energy monitoring in buildings. We're offering services in those arenas in fleet management and telematics arenas. One of the case studies in the report that you're going to be able to download at 1:30 is something called Envision Charlotte. I would encourage you to go there and take a look and search for it on the web. Envision Charlotte is fairly early in the process. It's a community-wide holistic approach to energy efficiency that really puts into practice the people-centered, efficiency, technology-centered, and service-oriented concepts that are involved that were discussed earlier by Neil. The goal of Envision Charlotte is to reduce energy use by 20% over the next 5 years. but it's also holistic, so it looks at water and waste and air quality. Involves 64 buildings that have been sensorized, and the energy information is displayed in digital-driven kiosks that are fed by wireless. There's about 600 champions have been trained in all the buildings. These are employees of the different firms that work in the buildings and have become advocates of it. It can be as simple as walking around their building and advocating with their colleagues about turning off lights when they leave a room and so on. So the initial push here is really the people-centered approach with just by having some energy data that's displayed on kiosks around the city and the advocacy by the folks involved. Over time, the plan is to install building energy management systems that would be similar to what you saw with the example from Empire State, and expand the kind of the savings that can be realized. I encourage you, this is early on this summer. The Duke Energy, which is collecting the statistics, expects to begin to be able to start publishing some of the results this summer for the energy savings that have been realized to date. But at the moment, they don't have any data to share. But do take a look at the report, and I'll hand it off now to the next speaker on the agenda.
Thanks, Larry. Next, let's go to Arkady Gurney with OPower.
Hi, everybody, and it's a pleasure to be on the call, and we're very excited about the report that ACEEE is releasing today. So our perspective on intelligent efficiency is very much in that people-powered segment that Neil discussed, and in particular, it's in the residential space. And what we've tried to do at OPower is think about what information about energy usage could we present to energy customers in their homes that would help them understand how they're using energy and how they can save energy. And the core product that we developed, which you're looking at on your screen, is a home energy report, which basically tells people, presents two kinds of information. How am I using energy in my home compared to similarly sized homes in my neighborhood? And then what particular tips based on my energy usage and information we bring in from other sources, so we'll typically know the weather and the square footage and how many occupants there are and whether someone is a tenant or a homeowner, what particular tips would make sense for me in terms of saving energy? And really our perspective on intelligent efficiency is to try to take an enormous amount of data, not just on how one home is using energy, but how it compares to the mass of homes around them, and turn that data into insight. And since we began this program with Sacramento's municipal utility 5 years ago, this has grown into a much larger program. So we are now working with 70 utilities around the country and in the UK, including 8 of the 10 largest US utilities. And there are now more than 10 million homes that are receiving this information, not just through the home energy reports, but also through website portals that we build for utilities, through email, through mobile apps, and other methods. And we now also have data from 40 million homes. So a lot of what we try to do is learn from the program to see what's effective. So we are constantly varying the presentation of the information and what information is presented, and looking based on the energy performance of the homes that are receiving the information, what presentation of the information, what tips are most effective in saving energy. And in that way, we're able to bring the benefits of the scale of the program and of running it in many different parts of the country, bring those benefits back to our clients, the utilities, from the benefits of that aggregate analysis. Let me say a little bit more about how we run this program. We run it like a drug trial. So we'll have a target group of homes that are receiving the information, and then a control group of randomly selected homes in the service area that are not receiving the information. And what we're looking for is the difference in performance. And based on these 70 clients and now 50 active programs and more than 10 programs that have been up for 3 years or more, we've seen pretty consistently 1.5 to 3.5% savings. That is, the people who are getting the information, the average home is using 1.5 to 3% less energy than the homes in the control group. And that may not sound like a lot, but 1.5 to 3% adds up to a lot. So this month, OPower and the utilities we work with have now saved a total of more than 1 terawatt hour, which adds up to enough power to power 90,000 homes for a year. It's also reduced an enormous amount of pollution, and this program has saved residential customers more than $100 million on their bills. And you know, the perspective that we have is as systems get more intelligent, as devices get more intelligent, as the grid gets more intelligent, there are enormous opportunities to save energy and to save money in this intelligent efficiency framework. But one of the critical nodes, and we think the most critical node in these systems, is going to be the occupant, the building occupant themselves. And that if you can't make them part of the system and present information in a way that allows people to make quick, informed decisions, that you're going to have occupants working against these smarter systems rather than working in concert with them. And so with that, I'll turn it back to the moderator. Thank you.
Great, thanks, Arkady. Next, let's go to Stephen Harper, is Intel.
Thank you. I think we need to, here, I said I was going to take over the slides. I'll take over the slides. Bear with me here for a second. So what I want to do is step back a little bit and provide a little bit of additional context and background to some of the specific case studies that my colleagues have presented. In very general terms, we talk about the macro story and the micro story. Analysts have taken a look at the footprint of the ICT industry in terms of energy and climate emissions, and approximately 2% of the world's footprint is accounted for by our industry. The other 98%, we believe, represents a great opportunity, and one of the messages here today is we can do a lot more, and we are doing a lot more on both the 2% and the 98%, while the focus of the ACEEE report is on the 98%. If you go the next slide, so what are we doing on the 2%, what we call the micro story? It's about the efficiency of individual devices. Well, first of all, Moore's law and the shrinking of transistors Moore's law is not a law, it's an observation. It's been up to the industry to keep pace with it, and we have. By miniaturizing circuits on a almost monotonous basis over time, we've greatly improved the energy efficiency at the micro level. Another thing that has helped is the change in form factors. We no longer have large desktops for the most part. Most of us now have mobile form factors of many kinds, laptops, tablets, smartphones, etc. And the data center, which has gotten a lot of attention and is a growing part of the U.S. and global electricity load, through the Green Grid, an industry organization, and other efforts, there's been a tremendous amount of progress in making the data center more efficient. So overall, there has been a laser-like focus, I think, within our industry to focus on energy productivity to get more performance for less energy input. So just to illustrate here in terms of Moore's law, this is using an example from my own company. On the left-hand side, you can see the performance increase in our chips over time. This is a little bit old. It ends 4 years ago, but the trend line continues since then. And there's a concomitant power reduction that's accompanied that. And again, this is driven by efforts within our industry to keep pace with Moore's law and the shrinking of circuits. At the system level, I mentioned, because we're going mobile as a society, that's helped. Basically, what's happened in the last 10 years is we've gone from predominantly unmanaged desktop systems with large CRTs to power managed, heavily aggressively power managed, in this case, laptops. And this is going to continue. The sheer ergonomic requirements of mobile devices require them for heat prevention as well as for battery life to be much more efficient. Now let's pivot here and focus on the macro story, the 98%. What is our industry doing in this realm? And I'll cover the outline here and then give some examples in the last few slides I have. First, there has been a proliferation of what we call the embedded market. So these are products like Johnson Controls, for example, makes that aren't ICT products per se, but they have embedded in them a lot of ICT content. And so, for example, in my company, growing the embedded market is important, and that's leading ultimately, I think, to the so-called Internet of Things, where everything will be connected to the network. And to a large extent, that network is going to become what people are referring to as the cloud. So supporting the cloud and making the cloud as efficient as possible is a big focus of our industry. We are busy as companies and as an industry piloting new applications of intelligent efficiency. There's lots of technology out there that can be applied in some of the neat projects that my predecessors have outlined, but there's a lot more progress to be made. A lot of companies, certainly my own company, is investing hundreds of millions of dollars through our venture capital funding arm in developing companies that are developing sort of the next-gen intelligent energy applications. And then through something that most of the companies that are part of this presentation and ACEEE itself are part of, the Digital Energy and Sustainable Solutions Campaign, or DESC, we're partnering with government to develop and implement public policies that enable ICT to do more. One of the key findings and better parts, I think, of an excellent ACEEE report is the focus on the need for smarter public policies to allow ICT to realize the full potential. So just quick examples of what I just highlighted. This is from my own company, an example of different applications in many different parts of the economy where we are developing, have developed silicon technology that can be used, for example, in wind turbines and advanced wind turbines. There may be as many as 7 to 10 CPUs to help better manage the angle of the blades and other aspects of the blade to make sure it's as efficient as possible to turn wind into electricity. I talked about the cloud. I think people tend to, what is the cloud? The cloud at its core is the data center. It's more than the data center, but it is the data center at the core. And the data center has gotten a bad rap because in the past, largely, data centers were not particularly well managed for energy efficiency. This has been a big focus of our industry, as I mentioned. The Carbon Disclosure Project recently commissioned a project which I think I would commend people to read because it does give a great analytical look at how efficient data centers really can drive huge efficiencies in the rest of society because it's the network that provides these intelligent efficiency benefits. Another example I mentioned, we're piloting new applications. My company just announced with Imperial College London and the University College London the Intel Sustainable and Connected Cities Institute in London, where we're going to be going out into the city in different neighborhoods and using sensor networks and other ICT technology, piloting and quantifying the energy efficiency benefits of intelligent efficiency. And then finally, I just wanted to show you some of the companies that are involved in the Digital Energy and Sustainable Solutions campaign that I mentioned earlier. We're active in the U.S. There's a parallel group in China. This is, I just noticed, not quite up to date because Schneider Electric is part of DESC. But this is a group that's focused between industry, ACEEE, and a number of other energy efficiency and climate groups and trade associations on telling the story of intelligent efficiency and getting smarter public policies in place. Back to you.
Great, thank you, Stephen. So let's transition now over to the Q&A session. First, let me just address a question about availability of the slides and audio. We will send a link following this presentation that will give you access to the webinar and to the audio. So let's see what other questions we have. Okay, one here relative to privacy concerns, and I know a couple of folks brought this up during their presentation, but a question about what are the most relevant privacy concerns and what's already been done or what still needs to be done to address these concerns. Perhaps Arkady with O-Power or Larry Plum, if you're interested in addressing this, and others can jump in if they'd like.
Sure. Well, this is Larry Plum at Verizon, and let me start. I think others can add to it. We think that there's certainly, when you get into the realm of energy information in people's homes and so on, you are absolutely need to be concerned with privacy issues. You're revealing what people's behaviors are and so on. And we think this whole approach is very amenable to recently the White House issued a program for the principles of privacy protection based on the Fair Information Practice principles and the development of kind of voluntary but enforceable guidelines and codes by different companies involved in different arenas that would be appropriate, and they would involve transparency, notice, and choice for customers so people know what's being involved, how their information is used. And enforceable because ultimately it would be similar to the Federal Trade Commission. Truth in advertising. If you don't follow your code, then there's the possibility for legal action. That's where the element of enforcement could come into play. In this arena, a number of companies that are involved in the call, Verizon and others, we've been involved working with the Future of Privacy Forum, which is an advocacy organization, on the concept of a SEAL program for home energy energy data. A SEAL program, like think of the Good Housekeeping seal of approval, that there's a third party that looks at practices and procedures of a company and certifies that it's a good actor, and as a sign of that gives the rights to display a seal. It also becomes a venue where people can if they feel like something's been violated, they can go to complain to this organization for complaint resolution, and ultimately can enforcement, as I described earlier. We're close to. We've made a lot of progress on this, and we should be in the news fairly soon. If people are interested in the follow up on this directly, I would encourage them to track down the Future of Privacy Forum and ask for Jules Polonetsky, who's the co-chair and director of the Future of Privacy Forum, and he could talk about it in more detail. Arkady, would you want to add anything to that?
Sure. I mean, I think Larry, that was very good, and I think I think the only thing I'd add is I think there are two perspectives that we have to the issue of privacy. One is that it's important for all of the actors in this space, whether they're the regulators or utilities or technology companies that are working in this space, to communicate back to the public very clearly what the benefits of the technology is. I think one of the challenges with the sort of early deployments in the smart grid was that a lot of technology got put into place that enabled the gathering of much more granular information, but I think it was communicating back to the customer what the value to the customer would be of this technology was sometimes not the highest priority. And I think that it's critical as the potential of smart devices, smart grid, and new innovative products and services come into the market, that leading with a very clear explanation to customers of how it's going to benefit people, I think is important to have that to balance against what are legitimate privacy concerns. The other thought I have is that it's important, I think, for companies and for regulators to be proactive, certainly on the issue of energy data. I think California has really led the way. They passed a smart grid data law, I guess it was 2010, and have had a substantial regulatory process in terms of defining that law. And I think it from our perspective, has been a very detailed and thoughtful construct, and like they have on many other issues of energy, I think California's approach to data and privacy sort of stands up as something of a model for the rest of the country. And I think it's probably better for regulators and for companies to sort of raise this debate and join the debate rather than for it to let it develop sort of on its own because problems arise. Great.
Thanks, Arkady. I have a question here from Philip. The question is, the concept of energy management, in particular the ISO 5001, is being promoted by the U.S. Department of Energy and U.S. Council for Energy Efficiency Manufacturing as a means for companies to save energy and money through systemization of energy performance and the adoption of the program. The question is, how does intelligent efficiency fit into with the ISO 5001? And Paul, would you like to address this?
Sure, thanks. I think ISO, first off, to recognize ISO 50001 is a management system that's set up, really to help you understand and build a management system around the use and management of energy in your facility. So, in fact, I think this is a very good example of intelligent efficiency. First off, you have to use people to understand what's going on and get engaged, document how your usage is being managed, and then build plans around that to manage that on an ongoing basis. So first off, you'll have to engage with technology, to upgrade systems, to make them more energy efficient. You'll have to, as you go further, and try to manage your energy efficiency on a continuous basis, which is really part of the Superior Energy Performance Program that the DOE is also pushing, which would come behind ISO 50001. These programs would both, so basically you'd have technology, you'd have the people involved, and it's just a good example of how you're going to use oversight and continuous management to drive further energy efficiency.
Great, thanks, Paul. Let me go to a question from Joe. This is directed to Stephen Harper. Regarding pushing all of these networks into a common cloud, what efforts are being made to allow so many diverse proprietary systems to speak a common language? In other words, what efforts are being made to allow a single piece of equipment to communicate, network with large building systems or even utilities?
Yeah, so that's a great question. One of the keys of the success of the information and communications technology sector over the last 40 years has been the development of open systems and the development of standards that allow technologies and devices to talk to one another. And the need for such standards and open systems, and the two are not precisely the same, but they're related in this context, is going to be greater over time as we move towards more and more things being connected in more and more ways. So there are a number of industry standardization efforts, significant SIGs as they're called. For example, Coalition that developed the Bluetooth standard. There are a variety of formal and informal standardization efforts underway. I have to say it's not all been seamless. I think anybody, for example, who's watched the wrestling over standardization in the smart grid space, it's taken longer and been more difficult and problematic than it could have been, but it's a priority for everyone, and notwithstanding the interests of different standardization bodies in different countries, I think great progress is being made.
Great, thank you. Let's see what else. Here's a question. Outside of OPower's work directly with utilities, the question is, I didn't hear a lot about utilities' future role in ICT. Can someone please address specifics of where you see utilities playing in this space?
This is Larry Plum-Bryson. I think when we talk about, you've heard the term smart grid. Smart grid is really the application of information communication technology to the operation of the grid. To use a simple analogy, the grid is a network that moves payload called electrons. The railroad network was the railroad, and the payload was the people and passengers. And when you overlaid the railroad network with a telegraph system, then you made that network smarter. People could show up at the station at the same time the train did. So the overlay of the electric grid with communications, information technology, sensors, communications, computing, can make the whole operation more flexible, more fluid, more efficient. So absolutely, this is directly involved. And if it extends beyond the grid into beyond the meter into smart homes and buildings, and the ability of energy load within a building, whether it's a heating and air conditioning system or some other load, to interact with the grid, turn off and on to match with the demand of what the needs are for generation and so on, and weather conditions. It's really part of very much a large system approach to applying information communication technology across the grid, but into the loads on the other side of the meter.
Thanks, Larry. Someone else want to respond, or I have another?
Maggie? Yeah, this is Neil Elliott. I agree with Larry. I think certainly the intelligent efficiency has a major role to play in the smartening of the electric system. The other role I think that the utilities can play is as a implementer of intelligent efficiency on the customer side of the meter, which Larry was alluding to at the end. One of the challenges, and this I think will be one of the policy challenges confronting the intelligent efficiency in its deployment, is making sure that the regulatory business models which govern our utility systems right now are going to send the appropriate reward strategies to the electric utility. Utilities are currently faced, probably for the first time in 3 decades, with major construction of new transmission and generation assets. As load grows, as old power plants are retired, as new environmental regulations make economic choices different than the mix we see today. Energy efficiency can represent a least cost energy resource for those utilities. However, the regulators are going to need to understand intelligent efficiency and the benefits and make sure that the regulatory framework which is in place appropriately rewards and incentivizes the utility to doing something that probably would not normally be within their best interest, which is selling less electricity or less natural gas to their customers. So this will be a major policy challenge, but makes the utility potentially a key player in the future of intelligent efficiency.
Great, thanks, Neil. And I think we have time for one more question. This one is related to the Empire State Building example, so suggest that Clay step in, but others can respond as well. Do tenants really care how much their peers consume? Do they have time to pay attention to this, or does potential cost savings really help get and keep their attention?
Well, some do, and I think it really speaks to motivations. What we find when we engage with tenants in buildings is that there's generally 1 or 2 people that kind of become champions, and they're the ones that are putting out the signs to turn out the lights, and they're the ones that are resetting the copiers for double-sided black and white printing instead of color, and they tend to take the lead. And I think what we've been doing for a long time is providing basic information. If you just give somebody a utility bill at the end of the month, or if you're a tenant in a commercial building, it may not even be the utility bill. It may just be the charge that you get, which is prorated across your square foot. It's unlikely that you're going to have any insight into the actions that you can take to reduce that, and very little insight into what exactly to do. And that's what this system attempts to do. It not only provides information, but it provides tips and guidance in how to make the improvements. I think what OPower has proven in the residential side, we're attempting to also prove on the commercial building tenant side, is that, in fact, people do care how they relate to others. And it provides some context. I really don't know if I'm paying too much, paying too little, if I'm efficient, inefficient, unless I can compare it to the other tenants within the building, and particularly with other tenants who do similar things in the building. Law firms tend to work extended hours and weekends, accounting firms maybe not. So that comparison will actually drive this kind of competitive spirit, and I think there's growing evidence that that is an additional kicker, if you will, that motivates people to make changes. Our expectation over time is that you'll actually have different firms challenging each other over a period of time to see who can run the most efficient. If you tie that with incentives, it could be a very powerful motivator for behavioral change.
Great, thanks. And unfortunately, we don't have time left to answer the other questions, but we got a lot of questions, and we will take these questions into account in our future work. Let me please direct you to a few polling questions. If you could please respond to these. And Neil, let me turn it over to you if you could offer just a concluding thought and mention ACEEE's future work on this project.
Yes, thanks, Maggie. I appreciate it, and thanks everybody for joining us this afternoon or this morning, depending upon where you are. I think as you can have heard from the remarks so far, we think intelligent efficiency is an important resource as we move forward in this space. Energy efficiency has been a contributor and can continue to be a major contributor, but we're going to need to continue to evolve that. What we've learned over the last 2.5 years is understanding something that is as multidimensional and complex is a challenge. And so one of the things we are going to continue to work on is going to be looking to better quantify and define intelligent efficiency in particular applications and understand what the specific policy barriers are and what are the energy savings and economic benefits that could confer from that. This work will be a continuing activity for ACEEE. We look forward to continuing to work with many of our partners on the advisory group who've been with us today, as well as the others, to help define that. And we see this as a broad space. There are going to be a lot of other organizations that will step in and take a major role, as we see with DESC and other groups out there. So we see this as a continuing activity for ACEEE, and we think actually a defining area for the energy efficiency community moving